to it. We've got a distribution here. We've got the distribution of the number of students. Number of units, sorry, like in credits, right? That these kids are taking in college. We've got the distribution of it. Seems like 15 credit hours is pretty large. A lot of times when you're at college, you get charged per credit hour up to 12 credit hours, and after that, usually there's a flat fee for 12 to 18 credit hours. It gets 12 or most. So it turns out that you can take 18 credit hours for as much as it costs to take 12 credit hours. I know when I was at UNM, each class was around 3 credit hours, so 12 credit hours was 4 classes. That's a lot, actually. That's a full-time load. 15 credit hours is 1 extra, and 18 is, you might want to have, like, I took 18 credit hours each semester, and at one point in time, that was bad. So you can see that the probability of a person taking 18 credit hours is very low. The reason why 17 credit hours is very, very low is because they're usually in blocks of 3, right? 16 credit hours, they might have had 2 classes with a lab or something. But you can see that these probabilities with the numbers that are multiples of 3, that's why those probabilities are high. Because college courses usually are in blocks of 3 credits. All right, so we also have tuition for each one. Probability is still going to be the same, right? Because tuition is just corresponding with how many credit hours you're taking. Or unit, because there's 3. So let's go ahead and calculate the mean and standard deviation of each of these, and compare them.
Yeah, I am struggle bus right now. Yeah, I think I figured it. Okay.
By doing this is laying down the groundwork for all of the other problems that are to come. They all build on this one. It's all about this college and their tuition and how much books cost and fees and finding combined means and situations and whatnot. All right, so first of all, I guess we're going to call this the distribution of x, because there's my random variable. I should have written this in a different place. I hope I have enough room. So this is our random variable x. So this is our random variable x, and then the mean of our random variable x is going to be equal to each x, right? So it is the sum of each x times the probability of x. So it turns out that that is going to be, and I hope I have room, 12 times 0.25 plus 13 times 0.10 plus 14 times 0.05 plus 15 times 0.03 plus 16. You know what I'm going to do? There we go, all to 18 times 0.015. Okay. I did all that kind of shorthand because I'm going to use my calculator to actually do this for me. And then the cool thing about doing it in my calculator is that standard deviation is a much more complicated formula, and it's going to calculate the standard deviation for me in a much easier way, or a much faster way and efficient way than it would take for me to just be plugging all those numbers into the calculator. So I am going to go ahead and insert a list and spreadsheet. I'm going to call this units. And then we'll go ahead and tab over, and we're going to have, we'll call it probability. I'm just going to call it, I think I'm going to need to call it prob u, because I think we're going to wind up, instead of calling it prob, I want to specifically call it prob u in case I wind up having to refer to this, or make another probability in this same spreadsheet. If I call everything prob, the computer's going to be confused. So I'll call this one prob u so that it's unique. And then our number of units began at 12, ended at 18. Okay, 12, 13, 14, 15, 16, 17. Ah, son of a monkey. 15, 16, 17, 18. So now I have to put in each of these probabilities as well. No. Okay. Come on, computer. You can be with me today.
I just want to know.
Alright, so we got.
I wish the stick was visible so I could know it's you.
Actually, I'm going to have to freeze this, and then you guys can enter this data while I enter over here. So, for 12, we've got 0.25. For 13 units, we have 0.1. 14 units, we have 0.05. For 15 units, we have 0.3. For 16 units, 0.1. 17 units is 0.05. And 18 units is 0.15. Okay. So now, just as I have showed you before, we can come on over to, not all the way over to I, but to C. And we'll call this prod u, like product, prod u, because what we need to do is we need to multiply each of these things, right? And again, right, at first you're like, why wouldn't you just have put all that stuff in the calculator in the first place? And the reason why is because for our expected value, or our mean, it's really easy to make that calculation, but it gets pretty complicated when you are finding your standard deviation. So then we're going to go here and call this equals, I just realized that we can go A, can we go A times B? Why have I not been doing this the whole time? Column A times column B?
Yes.
I think I can do it. I'm not sure. I've never done it before.
Well, let's find out. Whoa, crazy. Look at that.
It totally works. Why have I been writing out the stupid variable this whole time? Alright. So now we can insert a calculator and find the mean. Insert. And we're going to hit sum. right? And this is all of this is just pretty much a review of, can I do that? Yeah, it does not like that. Oh, I have to define another calendar, calendar, a column. I'm not sure how to do that. So I'm just gonna do the name. I called it prod view. And our mean, or our expected value, is 14.65. So, to interpret that, right, if we were to grab a bunch of students at random from the college, right, we'd expect for their mean units taken to be about 14.65. So we'll put that back here in our prism. Alright. And by the way, using this notation, saying plus, dot, 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 plus, is fully acceptable on the AP exam. Fully acceptable.
But like, how far can you go? Like, can you start right away, or do you have to go like, you did say that they're 12, 13, and 14? Do you have to do?
I think you have to do at least 2 in the beginning. So that's what we're going to do right now. Let's talk about the variance of our random variable x. That is going to be the sum of all of our x minus mu sub x squared times each probability of each x sub I, right? Probability each corresponding probabilities, right? X sub I, my God, X sub I, right? Where x sub I, the I is just representing 12, 13, 14, 15, all the way. Which turns out to be 12 minus, and I'm going to go really short on this because, unfortunately, I didn't make myself more room. 12 minus 14.65 squared times 0.25.
They know that's their problem.
Plus, and I'm just going to go ahead and abbreviate this, and that's going to be 18 minus 14.65 squared times 0. And now we're going to get our calculator to do this for us, and it'll save us a bunch of time. So let's go back to our spreadsheet. And then this one, we're going to... Whoa, now, Tiger. Alright. This one, we are going to call...
Can you do the product times probability?
I definitely can. So I'm going to go equals, and I'm gonna put in the exact same thing, right? I'm going to have each x, which we called, I believe I can refer to just column A. And that's going to go minus my mean, which was 14.65. I'm going to close my parenthesis. I'm going to square it. And then get out of there, and I'm going to multiply it times prob u. Let's see if it'll do column B.
It was only us. Yeah. Yeah. Did Chris
Now all we need to do to find our variance
We're gonna call you.
is to add all of those things.
Really confused over here.
So like, would you?
Alright, so we'll find our variance by going to our calculator. going to our calculator, okay, and going sum var u. Why are you freaking out today? Alright, so our variance is approximately 4.228. But what we really want is our standard deviation, right? So in order to find that standard deviation, we've got to take the square root of our variance, which is going to be the square root of, and I can actually go up there, copy that bad boy in there, hit enter. So 4.228.
Thank you, sir. I appreciate it.
Alright, anytime. 228, which means that our standard deviation is going to be the square root of 4.228, which we found out was, and that's approximately, right? Which is approximately 2.06. Okay. Now we look at the tuition. Here's the probability distribution. So we're going to have a new distribution T. It looks exactly the same, right? I'm pretty sure we can calculate that for new problems. All right, so let's calculate mu sub t. Again, to do this properly, you should always xi probability xi. You should always fill in put the formula in, and then substitute some values in. So that's going to be 600 times 0.25 plus, and I'm going to go ahead and just shorthand this, because otherwise we'll take a really, really long time on this lesson. It's really long. So we're going to have to put that all in our calculator. You know what? Maybe I can be clever. It's $50 per unit. It can be clever, right? Because we can transform this, right? So all I have to do, since it's $50 per unit, what we're doing is multiplying, right? We're transforming the random variable t by, it's a linear transformation where we're multiplying each of our x values by 50, right? And we have a rule that tells us that so I don't actually have to calculate all that stuff out, right? I've got a rule that tells me that I can just multiply it by that value. So that's actually going to be it's all the same. It's the same thing as 50 times mu sub x, right? Which is going to be 732.5. Man, that saved us some time, didn't it? What about our standard deviation? Multiplying does indeed change the standard deviation of my random variable. So that means that I can actually do 50 times my sigma sub x, which is going to be 50 times, I don't know why I keep looking at my calculator for it, but oh well. 2.06. Sorry, what have I done here? This should be sigma sub t. Is that, do we call this this? Yeah, we call it t. Cool. Alright, that was the only thing I was wrong
So should I wear my snowboarding gear?
That's what I'm gonna do.
I don't have to. I don't have to dress up because I'm not gonna wear
There's this like $1,000 suit in United States.
So in addition to your tuition charges, a full-time student in El Dorado gets $100 in fees. So that's going to transform all of this, and therefore our so if we're looking at the mean of the distribution C, that is going to be mu sub, where are we at, T? The last one was T, right? Was it T? Yeah. Yeah. Plus 100, right? So that is going to be, what is it, 732.5. All right. What is the standard deviation of the probability distribution? Huh? It should say the same. And what do you decide? 3.06? It will not change, because adding 100 to each is just shifting it, not changing our standard. All right. Oh, we're moving a lot faster than I thought. Okay, so we're gonna do a weird little segue. We're gonna step away from the university for a moment and do a normal distribution problem. Okay, so different type of problem. Before we were dealing with discrete probability distributions. This one is continuous. It says it's a normal distribution. In fact, it looks like it is normal with a mean of 17.2 and a standard deviation of 3.8. He is going to scale the scores by multiplying them by 4 and then adding 10. But let's talk about our random variable y. Well, what is that going to be? It is going to be 10 plus 4x, right? Our new random variable y is going to be each one of our x values, which is the score, right, times 4 plus 10. All right? So then the mean of y is going to be 17.2 times 4 plus 10. 78. And I already remember that. And then our standard deviation of our random variable y. And this is where people make mistakes on a problem like this, right? Don't want to transform it, don't want to add the 10. Don't add the 10, right? That's all you got to do. Realize that you don't add the 10, so it's going to be only 4 times 3.8. Why put a parenthesis there randomly? But here's one.
I would just love it. I would just
15.2. So, if we're looking at the distribution for the random variable y, it will be normally distributed with a mean of 78 and a standard deviation of 15.2. So there's our new distribution. What's the probability the randomly selected student has a scaled score of at least 90? All right, so what we're looking at is the probability that x is at least 90, so 90 or more. So we got to do some side calculation. Whenever we're doing a normal calculation, we should always actually find our standardized value, right? Find a z-score. So that's going to be x minus mu divided by sigma. Yeah? We'll go ahead and calculate the standardized value. And then also talk about what this looks at like in terms of our normal curve. So our mean is at 78. We're at 90, somewhere around there possibly. So what we're looking at is finding the area of this shaded region. Okay, let's do a few calculations.
You are 12 years old. I think it's like that.
Look at the top one. Points real.
You were the stupidest person I've ever met.
15.8.
Just cut myself.
Alright, 0.789. Which means that this value is less than 1 standard deviation above the mean. Just kind of refreshing, interpreting a standardized value, what it means. So approximately 0.789.
Black cakes.
And then from there, once we've entered all this stuff, we can just get our calculator to do it. Now, of course, you can go to your table, right? You can find that proportion, and that would give you the probability. But since I don't have my table handy, I'm going to go ahead and use my calculator to do it. So I can do this on my, I'm already on a calculator. So I am going to hit menu. And I'm going to hit probability. So the way to do this on your calculator, right? No table, table-free version, okay? And that's pretty much where I'm going to go next, okay? I showed you how to use the table back in chapter 2. Now we're going to use the calculator. We know what the calculator is doing. The calculator is doing a little calculus, assuming the table was created. So we go distributions, and we want normal CDF.
I don't remember that at all.
We were doing all this stuff, but we did it. We weren't talking about it in terms of probabilities now. We're looking at proportions, right? We said, okay, the proportion of people that are above or below this. Yeah. So our lower bound, and we're getting this information from this picture, right? Our lower bound is 90. Our upper bound is infinity. But our calculator doesn't know infinity. So the closest thing it'll do to infinity is 10 to the 99th power. It's a pretty darn big number. Big enough to assume that we're fairly close to it. Or at least the calculations that we're making are fairly close to the calculations you would actually make if it was infinity. It's close enough. Our mean was 78. Standard deviation was 15.2, is that correct?
That's my sister.
I'm really good at this, so. Alright, so we get a probability of approximately 0.215. Done it. I can't believe you've done that. My son is addicted to boxes. Like literally ideal. Like I come home from work and what's on my TV? Just great. I know, but
My sister's famous.
alright.
He went upstairs.
Back to El Dorado Community College. They've got a campus downtown, and luckily we don't have to actually do these calculations. They're done for us. We're going to use them later, though, so that's a good thing. You can just see the calculations done. Full-time students, they take only 3 unit classes, right? So there's no labs or anything like that. So we eliminated 13, 14, 16, and 17 unit classes. So here's the new probability distribution. So the mean is going to be 15 units. And so now we're calling this, probability distribution Y. And really, the reason why we're looking at this slide is because we need this number and we need this number. I'm pretty sure for a problem that comes after this. And then, right, we can combine probability distribution. So before we were transforming them, now we're able to combine them, and we can just straight up combine them, right? So if I was going to grab a student from the downtown campus and a student from the main campus, and I could expect that the number of units that the two combined were taking would be 29.65. Right, so we're allowed to do these combinations. That's all that is trying to get. All right. We got another one that all the work is in now. Oh. I'm like, why isn't there a spelling? Why is there an error? It's because I had to take a screenshot. I was like, I looked at it and I was like, this thing is, it's never done that. Okay. So another probability distribution is S, which we just came up with, right? That is, let me make sure. Yes, S was the combined units taken by a person by a student at the downtown college and the main campus. And you can look at the probability distribution of S. Right, starting at 24 because you need to take 12 credit hours at one, 12 credit hours at the other. You'll never ever have 25, right? So this probability is 0. What are we dealing with little y? We'll figure that out here in a minute. So we can calculate the mean, and we can calculate our standard deviation in the same way. We can also just add them, right? So you could use this probability distribution to add them. Or you could either just add them or use the probability distribution. All right, so the y is just the y in probability. Thank you so much. Here you go. Thanks for that.
Wow.
If you don't like orange, I've got another flavor.
Say yes.
So then the probability under 24 is actually 0.075. So there we go. Calculation technique. Okay. So tuition, fees, and books. The amount spent on books in the fall semester for a randomly selected student is okay, we've got B is our new distribution. The mean amount spent on books is 153, and the standard deviation is $32. So, we gotta find the mean and standard deviation for the cost of tuition, fees, and books. In other words, adding probability distribution C plus fees for a randomly selected full-time student. Yeah. So the problem with this problem is that you can't, because I think if you calculate mean, I need to actually double check, but you cannot, I'm sure that you can calculate standard deviation. And the thing is that these two things are not independent, right? The number of books that the amount of books that you're going to have to purchase is independent of the class. I'm sorry, they're not. Is dependent, right? These two things are not independent. I'm pretty sure I said that wrong. Because if you take a class, right, you might have to buy 4 books for that class. And in another class, you might have to buy 1 book. You know, you might have to buy 4 books that are $80 a piece, or 1 book that's $200. And by the way, yes, that is how much the books cost. They are in the hundreds of dollars for college. So look forward to that. Make sure you got some money set aside. If you get scholarship money, they usually give that to you. It acts like they just load that bad boy in your account at school. So the thing to remember is that these two things are not independent.